Buenos días nuevamente, bienvenidos todas y todos ustedes a este segundo día, segunda mesa de la Conferencia de Grandes Datos en Ciencias Sociales y Políticas Públicas, que está organizada conjuntamente por el Colegio de México, al cual agradecemos infinitamente su anfitrionía y los recursos que ha dedicado, y el INEGI. Welcome to our speakers this morning. It's an interesting panel. I forgot all my notes, but what I saw is that this is going to be very interesting because I have the pleasure of being to both three institutions and have an idea of what each of them are doing in this front. Let me start introducing our speakers this morning. We have three different speakers from three outstanding national statistical offices. Right on my right-hand side is Tom Smith. He's Managing Director of the Data Science Campus of the Office of National Statistics, that's in the United Kingdom. He joined the ONS in 2017. He was co-founder and prior to joining ONS, Chief Executive of Oxford Consultants for Social Inclusion, a research and data spin-out company from the University of Oxford. Tom has more than 20 years experience using data and analysis to improve public services. So we have a representative from ONS, especially from the Data Science Campus, which is a great outfit in Newport, Wales. Then to his right, we have Eric Rancourt. He's Director General of the Methodology Branch at Statistics Canada. He's on this side of the Atlantic Ocean. He's part of our NAFTA friends. So, but in Statistics Canada, he's been for more than 29 years. He looks younger, but 29 years in different responsibilities, such as Director General of Strategic Data Management, Director of International Cooperation, and in that capacity, that's what we had previous collaborations with STATCAN. He was also Director of Corporate Planning, Head of Research, Production Manager of Survey Methodology Journal, and Researcher. So he's very well experienced. And then on my far right, we have Sofie de Broe, okay. She's Head of Methodology and Scientific Director of the Center for Big Data Statistics at the CBS. CBS is the National Statistical Office of the Netherlands, and she's based in Heerlen. She did a master's in demography in Leuven, then previously a bachelor in sociology in Ghent, Belgium, and she has a PhD in social statistics with an emphasis on reproductive health from Southampton in the UK. After working at that University of Southampton, she worked for 6 years at the ONS. So we have two people that have experience at ONS. But Sofie was not in Newport, but in Titchfield, and she was working on migration statistics. Then she moved to Germany, and since 2015, she works for CBS in the Netherlands with a main focus on big data methods. So the purpose of this session is to discuss how the different work that each ONS have been doing regarding big data have transformed themselves into official statistics. Let me tell you that both in the ONS, the Data Science Campus is a very interesting place physically it has a complete idea of isolating a group of researchers or data scientists that basically work in tandem as a creativity lab where many of these ideas can flourish and then be transplanted to other areas. So I'm really looking forward to what Tom has to say about that. I also had the opportunity to visit CBS Big Data Research Center, and by far CBS is one of the leading institutions in the analysis of deep data and applying that in different spheres, and I'm sure Sofie is going to talk about that part. That together with a conference or media center at CBS is one of the main characteristics. And I've been also to STATCAN, but I haven't had the chance of looking specifically on the work about big data, so I'm looking forward also to what Eric has to tell. So let's start with our first speaker. Each of you will have 20 minutes time for the presentation, and we're going to start with Tom. Tom, the floor is yours.
Muchas gracias. It's okay? You can hear? Excellent. Buenos días, distinguidos participantes. Muchas gracias INEGI y el Colegio de México por la invitación. Tengo el honor de sumar a mí, pero hablo poco de español, so I will continue in English. Discúlpeme. Okay. So today we're going to talk about what government is doing around big data. Yesterday we heard from industry, we heard from academia, and today we will be looking at national statistics institutes and some of the other work in government. And I will talk a little bit about the experience from the UK and particularly the work from the data science campus. And I will start just by kind of overviewing National Statistics Institutes. Many of you will know this, so I will skip quickly. But the key point is that in every country in the world, National Statistics Institutes publish the data that provides the infrastructure for the country, the critical data that is used to make decisions. So on questions around the economy, where we have GDP or price indices, those are used by businesses, by central government, central banks, for big decisions. On the census and population estimates, those are the data sets that are used to resource allocate, provide resources to local areas, schools, doctors, GPs, and so on. So the data that is published by the UK Stats Institutes, by INEGI, by other stats institutes around the world is infrastructure, like roads, like bridges. It is critical information for the country. So why do we need something like a data science campus? 3 years ago, in 2016, the government, the Chancellor at the time in the UK, commissioned a review of how economic statistics were published and the capability of ONS particularly, to use all of the data sources that can tell us about the world, that can tell us about the economy. That review was carried out by Professor Charles Bean. It's known as the Bean Review. And it published in March 2016. And 1 day later, we agreed with the Treasury, the Finance Ministry of the UK, to fund a special program that launched a new data science campus and that guaranteed funding for 2 years only. Also, alongside this, we funded a special program, a new group, the Economic Statistics Centre of Excellence, which works with ONS and academic groups. And I came in to run this group, and people said on day one, you've only got 2 years funding. What's that about? How can you possibly change anything in government in 2 years? But I've come from industry where 2 years funding guaranteed is an absolute dream. If you can be sure that you can carry out your program for the next 2 years, then that planning and that delivery enables you to build and scale and really try something interesting. So we had a 2-year funding program from the Treasury, from the Finance Ministry, and after 2 years, we then met our targets and they agreed another 2 years. So this was a special program, and the first message from me today is that use every source, every opportunity you can to get funding from the finance ministries, from every source for your innovation programs. So the Bean Review was very critical of the ONS. It said we lacked capability, we were not at the cutting edge, we were not world class, but we used that as an opportunity to fund the programs that could help us move up in some areas like data science. So that's my first message. The other messages from the Bean Review, and the areas that up in red that I've highlighted, were really interesting for a National Statistics Institute. They talked about better use of data. So thinking about the outputs, but better use of the information that we hold internally, but also collaboration with partners, people outside the Statistics Institute, people outside government. So that gave us a real purpose, a real remit to work in collaboration and partnership with industry partners, with other academic groups, and so on. It also talked about recruiting a group. And so the data science campus has recruited from industry. About a third of our data scientists have industry experience. We've recruited from academia. Similarly, about a third of our group has come in from academia. We have rolling partnerships, secondments, and placements. And then we have a good third of our group from civil service, from government as well. So we use all the talents, all the skills, and that's really critical. So that's the background. What do we do? Data science that we heard about yesterday talks about satellite data, talks about mobile phone, technical, very cool stuff. I want to take a few steps back, a few years back. So something you're looking at here, this is the Phaistos Disc, which was discovered about 100 years ago, and it dates from 3,500 years ago, from ancient Greece. This is the first written language that we've been able to decipher in Europe. There may be others in the world, I'm not sure. So this is Linear B. We deciphered it after 50 years. It's a very interesting story. It's like a detective story. And when it deciphered it, what did it come up with? The earliest written language we are able to read in Europe, dating from 3,500 years ago, is data on what palace storehouses held, on what was being purchased or brought in. It's admin data. It's administrative data records. And so the history of using administrative data goes back a long, long way, and every national statistics agency in the world is either using or trying hard to use admin data in every sense, in every way. So my kind of challenge out for all of us is think very hard about the sources of data. There are lots and lots of sources held by every single organization out there. Lots of other examples, but I'm going to kind of flip the question now and say, why do we need this kind of level of data that we were talking about yesterday? So satellite imagery or mobile phone data. What value does that add to a national statistics agency? We have our nice methods, our robust methods for producing data sets. So I'm going to flag up something here. This is a price for a single item, branded standard item. It's a game called Monopoly. Many of you will know this. I played it as a child. If we think about inflation and price indices over time, we tend to think of a few % increase here and there. In the world that we live in now, prices fluctuate massively on a minute-to-minute, day-to-day basis in all fields. So the idea of price indices becomes a very different debate, a very different question. So the range of fluctuation here, where you're seeing something like from £6, so sterling pounds, up to £20, and back down again in very short periods, shows the fluctuation of prices for a very standard item. And the key point here is it is a complicated world. Things move very quickly, and if we want to understand what the economy is doing, we need to use different sources, so administrative data, big data, whatever we can get our hands on. And that's simply to understand the challenges that we've been working on for a long time. And it's not a new challenge, because many of the problems we're looking at are very similar to the problems that people have been looking at for 50 plus years. So I kind of come back here to big data. This is big data circa 1939. So these are London Underground workers sorting 4 million tickets for riding on the London Underground tube. So if you think your data's bad, come and look at this. This is what people were trying to do and have been trying to do for decades, using all sources of data to understand and optimize services. So here they're using the tube data, the tube tickets, to optimize, to put on which trains, decide where to run trains, which trains can we cancel without users experiencing a worse service. Roll forward 75 years, and you have exactly the same challenge. But now we have access to credit card data, tap-ins, tap-outs. We have potentially Wi-Fi data, so you can see people moving through the system. There are all sorts of sources that you can use, but you're still looking at the same problem. How do you optimize tube transport? What are the flows like over time? What do travel to work areas look like? And so my feeling and view on big data here is that you are using new tools for old problems or shining new light on old challenges. And I'm going to finish this kind of intro section just with a kind of a reflection on big data. And I'm not sure it's a very helpful term, and I know we've got it in the conference, and I know many groups use this as in their title. But big data itself, the definition is complex and hard, and people argue about it, and it's often, one bite more than we can easily deal with. And we look back, 50 plus years, big data there is not big data for us now. So for me, I think we change this, and we talk about data from all sources. So big data by people I come into contact with, it's not really very big, but it's stuff that other people hold. It's organically generated. It's not data that we've defined through a survey. It's generated by some other process. But we have to go through exactly the same challenges. We need to understand the bias and the skew and whether groups are represented or undercovered. All of those sorts of things, we have to understand the quality of the input data. And that means that we can then start to use it. So that's the kind of starting pitch, I think, maybe to kind of set the scene for the work. So the data science campus itself, we apply data science, and I'm happy to talk about the definition there later on, and build skills. So we're also building capability, and I'll talk about that a little bit as well. But the key point here is for public good and social impact. So all of our work has to produce an impact in terms of the public and social fabric of the UK and international. Note that this doesn't talk about statistics. It might include producing statistics. It might include producing research. It might include helping people build skills so that they can use their own data. So there are lots of things there. And we have a series of objectives, which I won't go through in detail, but just put them up there, as well as the kind of the standard outputs around, as you'd expect from the Statistics Institute. We are interested, of course, in statistics and evidence. We want to test new data sources explicitly, so we can say, we have tried all of these sources. We know that this one doesn't really add much. This one may be useful in these contexts. So we want to be able to try those. This comes back to the Bean Review Challenge, which said you need to be at the leading edge of understanding how the economy is working and using all forms of data and techniques that you can to do so. We also have objectives around building data science capability, so capacity and skills, around collaboration, and then around reuse. So much of our work is working with partners in the UK and internationally to help reuse the tools and techniques that we're looking at. Okay, so let's go on and look at something a bit more concrete and give some examples of the work. I'm going to come back to the Bean Review here. Much of the Data Science Campus program is looking at what can we do that produces faster outputs, faster results. And a good starting point here is think about the users of your data. If your users need to make decisions this week, then producing something next year, which is 100% robust, is not useful to them. Producing something this week, which is 80% robust, they will use in their decisions, hopefully. So the value of data and statistics and research and your outputs have to be seen in the value of the way that they are used. So the impact that it has on decisions and users. And so this point from Charles being, the longer a decision maker has to wait for statistics, the less useful they're going to be. And that's a real challenge to statistics institutes that have long timetables for producing outputs. It's a real pressure on us to do things faster or to produce interim results or experimental outputs, things like that. So let's look at a very concrete example, which for the UK is an important one. So like all or many of the economies around the world, just over 10 years ago, we had significant downturns. So I don't know if so this is GDP growth, and then in 2008, we had a significant hit. That won't be news to you. It took many years for the economy to recover over that, like many other countries. Change to GDP, huge. The critical point here is that academic researchers have looked at the value of data for decision makers to be able to respond to that downturn. Because things like knowing that that downturn was happening, that can be used by central banks in reducing interest rates, increasing the flow, the supply of credit to industry and so on. There's a very direct lever on how this data is used. It's got a clear flow through from the NSI right through to the output on the economy. And the estimates that were produced by the National Institutes for Economic and Social Research in the UK were that earlier data would have been worth £12 billion. That's just under 300 billion pesos. Think about that, just the value of data, not the impact of the downturn on the economy, that's much bigger. So this is the value of knowing that this was coming and that you could turn down the inflation rate and free up credit. So the value of having faster information there is huge, and unsurprisingly, many agencies are looking at what we can produce that provides faster outputs and so on. So just going to look at 3 data sources very quickly. But at 9:30 a.m. this morning in UK time, which was exactly 6 hours ago, we published our monthly outputs from these new data sets, which produce a rapid activity set of measures for the economy in the UK. The first one is looking at business data. So at individual level, business returns for value-added tax. Many agencies have access to this and use this, so it's not an unusual one to look at. But we now provide direct measures coming out before building these into GDP measures and others. The second data set we look at is road traffic. Around the UK, we have 10,000 sensors. They look at every minute or so what traffic's passing and the length of those vehicles. So we can look at lorries, which trade in goods and so on. The third one is shipping GPS. We have access globally to ship positions updated every few seconds for shipping above a certain weight. The UK is obviously an island, so trade and goods, much of it by volume comes in through ports, so knowing that data really can help us get a quick handle on activity. So those are 3 data sets. We've looked at lots more, but these 3 we're producing now as regular monthly outputs. And they produce a good indication or information on what is happening in the economy. They're not GDP, they're not a proxy for GDP, but you can use them as part of a nowcasting. And we've looked back and tested this. If we were running these indicators 10 years ago, we would have identified the recession 5 months earlier than the full official outputs. Now, there were lots of indications during those 5 months, but think about that for decision makers to help them make faster decisions. The media is very interested in this, so if you're talking about reputation and brand around your National Statistics Institute, this sort of thing goes down very interestingly in the media and produces a competition in the space of early and rapid indicators. There are lots of commercial sources here. We have access to data that means we should be providing out rapid indicators like this. I'm just going to skip through some other examples, but happy to talk more in questions. So the first ones, we look very differently at sources of data. So yesterday we looked at image data and mobile phone movement. Text data, there are vast troves of information of value in data sets that are text. We've looked at a number of projects here, so including, in this case, we have text data manifests on what lorries are carrying, what ports and so on are carrying out, so we can analyze and classify that data in real time and get a sense of what's changing, what's being carried and so on. What does internal trade look like? We've produced and published this out as reusable code. All of our work is open, so it can be reused by other groups. And lots of other projects around natural language processing, NLP, we've been working on. Next project, or next piece of work. We're very interested in imagery data. We're doing some projects on satellite, as you would expect. But one to bring out here is Street View. I think this was mentioned yesterday, but you can use street-level imagery and deep learning networks to essentially categorize and classify images. We've been looking at this for environmental quality, so producing low-level, hyperlocal measures of the environment, which you can then produce around the UK. Now, there's an interesting point here. Google have changed the terms and conditions on this data set to specifically stop this type of work, which is an impact, perhaps not a good impact, but I'll bring this up in questions. Working with data that is held by other organizations is inherently tricky. The collaboration and the discussion is important, and examples like this kind of raise that. We also, you'd be very unsurprised to hear are interested in banking data. Some of the work that BBVA talked about yesterday, very interesting, we're doing similar. The way we've worked this with as a national stats agency is seconding economists and analysts into a bank to run analysis on their system before publishing that out. So we're looking at the similar kind of local or regional household spend measures and then retail price indices. So similar to we saw yesterday. Final one on the examples. Government is interested in saving money, always. It's estimated in the UK that we have 16,000 statistical publications each year. You may have similar. It's an eye-watering amount. Being able to automate the production of statistics and the production of the reports gives you a real way of saving money, of efficiencies. It gives you a real way of tracking errors, of audit and transparency. So it's a big step. It's not data science in the type of analysis that we're looking at, but it's very, very interesting for parts of government who are looking to save money and so on. So the final bit I'm going to leave you with. I talked a little bit at the beginning about building skills. Many of our data scientists also get involved in this, but we've also built a dedicated training and capability program which starts from apprenticeships, so taking people literally from school and taking them through a vocational, so a 2 or 3 year program, up to degree level, but working within ONS, within the stats agency. We have accelerators, so mentoring programs across government. We now have a master's in data analytics and data science, which we commission or sponsor people across government to go through. And we're working with universities around the UK, so we have a joint PhD program with the Alan Turing Institute, which is where Omar was from yesterday. We have partnerships with doctoral training centres around the UK, and our first joint appointments are coming up this year. So readers in data science jointly appointed between ONS and universities. So this idea that there are skills around the system, there are data sets around the system, and national statistics institutes need to respond in order to make best use of that data and best use of that skills. So it's a really hard area, but there's a lot of opportunity and so on. So I'm going to leave it here and just around kind of these ideas around building skills and just kind of highlight the 5 lessons from today. If you're looking to build a program around innovation and data science or looking at new sources, use every opportunity for funding. And I'm very happy to sort of exchange and share our work there. Big data gives you an opportunity to do things faster. Often people say, why do we need things faster? But actually, there are some really concrete examples where that is critical information to provide. Think widely about possible data sources. There's data everywhere. We need to be very critical on its quality and apply our kind of put our proper statistics hat on. But there is useful data out there. We decided in the campus to bring skills building and delivery together, which is why we do both the capability and the projects. That was really important to us. We feel that actually it's hard to run data science capability without having that capability yourself. And then the final one, this is a new area. We're all learning. Every single place I've talked on this, people are doing stuff that genuinely blows my mind. You have access to data that we don't. You have access to skills and partnerships that we don't. So there's a great learning opportunity. So thank you very much.
Thank you, Tom. Very interesting. Now I'll give the floor to Eric, please. Eric.
Muchas gracias. Good morning, everyone. Buenos días a todas y todos. Con mi colega, quisiera agradecer a INEGI y el Colegio de México para la invitación. Y yo también Hablo español un poco, pero la presentación será en inglés. Bien. I would like to share with you examples of how we have been using different types of data at Statistics Canada, and how we are intending on using even more of the different sources. There's a lot of what we do that is parallel and similar to my colleagues here, but I'd like to give you some specific examples, real concrete examples of not just what we intend to do, but what we have been doing. Statistics Canada has embarked on a journey, on a modernization journey a few years ago, and that is completely changing the way we perceive ourselves, and also we want to change the way that we are perceived by society as not just a data cruncher organization in the corner of the government, but as a first-hand organization that is contributing to decision-making and policy-making. So a few words about the context. I'm not going to spend too much time on the context, though, because being here is a proof that we understand the context. I'll say a few things about the challenges that many of us, maybe all of us, are facing, and then I'll expand a little bit on the modernization endeavor that we have at Statistics Canada, how we have been using new data sources, it says surveys, but it's sources, and what are we envisaging for the future. So, as you know, we are in a rapidly changing society, and it's not new. Already in 2014, the United Nations had a report on the data revolution. How can we tap onto the data and better answer different questions that are posed to national statistical offices? There's a proliferation of data. I'm not going to expand on that one. We're going into a digital world. Everything is now possible to have at our hands, even things like Google Home, you know, and very soon our refrigerators, actually it has started, our fridge are going to tell us what food is out of date and what needs to be changed and bought, and I might come back on that. There's some fake news, there's some data that also that are of questionable quality, and I would venture to say that there's no data that is of bad quality. There's uses of data that are of bad quality, because if data is well analyzed and well processed and found that is not of quality fit for use, then if it's not used, it's not a problem of the data. And if it's used when it's not fit for use, then it's a problem of the data users, not of the data itself. There's an immense appetite for data. There's a demand by decision makers, by managers of statistical programs, by society for data. And at the same time, there's there's an understanding of what data is, what data means, what is the usefulness and what is quality of data. There's a low level of awareness, of complete awareness of what this is. And so national statistical offices, by producing official statistics, have a responsibility to educate, teach, and inform society about what is the importance of quality data. And of course, there's Sustainable Development Goals, which has, I would not say completely changed, but which has been a big impetus to enhance and change some of the ways we conceive how we produce data. And there was a presentation yesterday on some aspects of this. So some of the challenges that are more specific to Statistics Canada, but probably most of them shared by other statistical organizations, we have declining response rates. It would be easy to answer every question by running surveys and asking all the questions if surveys were easy, but it's not easy, it's expensive, and the participation rate is going down on a continuous level if you look at the response rate over time. So we need to find other sources to answer questions. There's an increasing demand. I talked about that, and I'll come back on the timely and granular. And also over the years, statistical offices, Statistics Canada, we have suffered some budget cuts, and so the program output that we have been producing from traditional means has been going down. That will continue to be the case if we continue to use traditional means, but there's all the data, there are new methods, new techniques that we can use, and so we should and are embracing those. There's also competitors. There's a lot of organizations, private, public, that are producing their own data that are sometimes fit for use, but sometimes not. And so the Statistical Office has a mandate to inform society, but also is challenged by having other departments, other institutions producing data that sometimes are shiny objects that are picked up very quickly by decision makers, and they may not be the appropriate information to do that. And especially the fact that now there are machine learning, AI, and these are good methods. I have nothing against that. We are using those approaches, but sometimes the way they are presented to people who don't know statistical techniques, it is a challenge for statistical offices to adjust its narrative and adjust the way we present our outputs and our processes. And as I said, quality is an issue that's not always front of mind to data users, and it is the responsibility of an NSO to bring that higher up in the mind of users. Just a few more things on some of the drivers. They are not necessarily new. They have been here kind of forever, but there's a new emphasis on some of these. And the first one that we live daily at Statistics Canada is the need for real-time information. Speedy, quick information has become something that is valued much more than quality. We're about to finish the month of May, so on June 1st, people are not going to be interested in receiving estimates for February or March or April. They'd like to have on June 1st the May estimates. Actually, they'd like to have the June estimate on June 1st, and probably July as well. So this is posing lots of challenges to the Stats Office. We are capable today, every statistical office is capable today of producing the May estimates. But what is the quality? What does it mean? And does it constitute official statistics? And how trained and ready are the users to live and work well with preliminary data that is of much greater variability than what we have been producing? So not only do we have to learn on how to change our narrative, learn how to change the way we process data, but we have also to build capacity in the users in adequately using the information we produce. And then efficiency is something that is always present in all our activities. So 2 years ago, Statistics Canada decided to embark on a journey of modernization that is built on, that is anchored in 5 pillars, the main one being making a real effort to be much more user-centric than we have been. So not just producing data because it's part of our mandate, but listening, we have been listening, but much more proactively into the needs of society, and not being in a responsive mode where there's a committee that's looking at some health issue, they're debating, and then at the end of 6 to 9 months debate, they identify a need for data, come to Statistics Canada, and then we answer, yes, we will provide you this data in about 1.5 to 2 years. That's unacceptable. We need to be at those tables. We are now at those tables, and the moment we see issues surfacing, we can start looking at what data do we have, what kind of alterations to our program can we make, so that by the end of the policy making, either we have the data or we are on the verge of producing it in a very short period of time. So being user-centric is really at the heart of the philosophy shift that we're imposing ourselves. And then there are 4 other pillars, using much more leading-edge methods, much more modern methods, and integrating information, building capacity in the users, but also building capacity in the rest of the national statistical system. Not only Statistics Canada produces statistics in Canada, other departments do. And so how do we equip them with the same tool chest and capacity? We need to share and collaborate. Tom has emphasized that, and this is, in the complex world that we have, it is no longer possible for one organization to master all aspects of statistics. So we need to team up with academia, with other partners, with the private sector. This is absolutely essential in the complex world in which we're living. And then we have to build a modern workforce, and we continue to build modern workforce and workplace so that we are trained and retrained for the new needs, the new context, and using new methods. So concretely, what does that all mean? It means that, yes, we have been using admin data. We have been using admin data since 1931. We have been using it to build our frames, to determine the strata, to do editing and imputation, to calibrate estimates. But it's been a paradigm where it's a survey first, and admin data is used, like the survey is the main course, and admin data is like salt and pepper that we put on it. We're shifting that around by saying we're going to go admin first. So let's try to see what already exists. And then, and only then, if needed, there will be a survey to fill in the gaps and or measure the quality of the admin data. So now the main course is the admin. And here, when I say admin, I don't mean data produced for public programs, administration of public programs. I basically mean non-survey, so alternative data, satellite, whichever. And so this is a complete shift in the mentality of how we produce statistics. And it has impacts on the theoretical framework that supports this, but it also has impacts on how do we access, how do we acquire data, how do we produce our statistics. And we've adopted a quality framework in 9 steps, and I could provide you information if you're interested, where, let's say for a moment, let's assume the following. Every unit in the population is going to be caught by a file somewhere in society. The stats office has access to all of it. There is no record linkage error. There's no response error, no non-response error. The concepts match what we want to measure. The variances are small. If that is all true, we could produce perfect estimates, but there's going to be departures from these assumptions. So measuring quality of programs is essentially trying to measure the departures from those assumptions. So maybe instead of running 350 surveys for 350 programs, maybe we use admin data, and maybe we have 9 surveys that are dedicated at assessing the departures from the assumptions I mentioned, and then a few surveys here and there to fill in the gaps. So maybe we can reduce by 10-fold the number of surveys to produce the same kind of information. So this is the meaning of modernization. To do that, we started testing it with some surveys, not in research mode, but in actual production mode. In Canada, in October last year, cannabis became legal, and so we had to produce estimates before and after, and there was no way we could produce a survey asking Canadians, how much cannabis have you used in the last month? How much did you pay? Where did you get it? And that's not possible. So we had to use other ways, and so we started crowdsourcing the information and trying to produce experimental estimates in a way that we have never before. And so since January last year, we've been producing estimates of cannabis price and a number of things that is completely outside the realm of survey taking that we have had before. The second pathfinder is the housing program. This is the first program that is entirely based on admin data. There's no survey at all happening. It's using the property assessments from the city data. It's using information from the insurance companies. It's using information from the electrical companies, from driver's license, and all mixing that so that we have a picture of who owns houses, what are the prices, where are they located. And this is the first program that is entirely admin-based. There are issues about quality along the lines of what I explained, but now we are setting up quality quality measures and maybe surveys or processes to measure the quality of those. Just a few words about the tourism program. This is one where we are looking at telephone information to see where people are moving, and is the IP address from their telephone coming from a different country, coming from Canada, what's the movement. And this is mixed with payment data that we get from credit cards at an aggregated level, so that we can have the total expenses by some low-level information. And we are using small area estimation. So we're using small area estimation, using payment data, and we're trying to mix that with telephone information to see where are people coming from. So these are not tests, actually. These are published estimates that we've been using for cannabis, housing, and tourism. And low carbon economy is not so much using new data sources, it's just a new way of combining survey data that we have in-house. So how do we go about doing that? We've created an innovation lab at Statistics Canada where people have access outside of the internal network that we have within the office to the open world. So being able to use open libraries from R and Python and not being constrained by the confidentiality process or systems that we have at STATCAN. And people are, we're conducting hackathons and trying to completely change the way the constraints exist around the employee reality at Statistics Canada. We created a data science accelerator, which is aimed at producing fast proof of concepts and trying to show, yes, this can be done. And this is mixed with another data science center that we created, the Data Science Center of Excellence, which is tasked with looking at, okay, how do we make that sustainable? And what are the underlying assumptions? Do we have a response bias? Do we have a non-response bias? And yes, the proof of concepts got us far quickly, but how do we make that usable in the programs? We've realigned the methodology research program to much more modern methods, more modeling, more use of machine learning, and increased use of qualitative data. We've created an R&D board that is specifically looking at how can we enhance the speed at which releases can be made, so getting closer to real-time production of estimates. And we've enhanced the partnership and work with the School of Public Service and other organizations to build capacity beyond Statistics Canada to the other departments. We have been using satellite images to produce the crop estimates. Now we're using a model that has been built manually, I would say. Now we're looking at machine learning to automate those models and do it for much more types of crops and expand that to other types of features on the ground. We have been using scanner data for some aspects, some types of expenses in the current price index. We have used the payment data for tourism. We're looking at the possibility of using payment data at a micro level, but this is creating some issues in terms of transparency, in terms of ethics, the difference that might now exist between the legal license that the Statistics Office has and the social license. These used to be assumed to be exactly the same in the past, but now there's a little gap that is being created between the two because of some worries of society, but also because of complexity of the new methods and new types of data we're reaching into. For cannabis, we're studying the use of wastewater analysis to see what is the total output of THC in cities. Where are we headed? This is my last slide. We're trying to change the agriculture program into what we call Ag Zero, where we would not survey any farmer. We would just use information that exists, and we call it from farm to fork. And you can think of a little piglet that is born. We put a tag on its ear, and then we can follow it all the way to basically your plate. So the Inspection Food Agency, if they want to make a recall, the information would be passed all the way through to your fridge in the future when we go 5G. But also, in terms of statistical system, we can look at production, inventories, transportation, and wholesale and retail. We're looking at the life trajectory models. There's an opioid crisis in many places, quite heavily happening in Canada. A status office can produce how many people died last year, but that's not as important and interesting as what are the life cycles and the path and the characteristics that can explain someone is going to die or not. And so we're looking at machine learning and AI to analyze the data we have. And that is combined with using qualitative data that we can harvest in the field, maybe through focus groups and all that. We're looking at non-probability samples, and we are starting using social media information. We're working on sentiment analysis, trying to produce information from that. And this is only the beginning. So that's a small sample of where we are, where we're headed at Statistics Canada. Muchas gracias.
Thank you very much, Eric. Muchas gracias. Now it's the turn to listen from the CBS experience. So, Sofie, you have the floor, please.
Okay. Qué gusto de estar aquí. Bueno, muchas gracias por la invitación. Muchas gracias, estimado señor Santaella, la gente de INEGI, Colegio de México, los alumnos. Después, bueno, hace 30 años yo era estudiante de intercambio en Celaya, Guanajuato. Y bueno, después de 30 años es un placer de estar de regreso y de comer chilaquiles en el desayuno con salsa picante. Bueno, voy a hablar en inglés porque no quiero que mis compañeros se sienten mal. Entonces, okay. So I would like to talk about big data to improve policy and decision making. And of course, we can argue that we always had a goal to improve policy or produce statistics to help policymakers, but somehow with the availability of new data sources and new techniques, we have become a little bit more critical about whether we were fulfilling this role properly. And we were looking how can we do it better with the new raw material. Because it's a little bit too easy to say, look at the tables on our website and good luck with it for your policy making. So we're trying to do it differently this time. This is the forward's the other one. Okay. So how do you go about this? You just set up a Center for Big Data Statistics. That's the easy bit. And so CBDS, the Center for Big Data Statistics, is actually a separate unit within Statistics Netherlands. It has a very strong connection with the statistical divisions. And in principle, we innovate the existing official statistics by making them real-time as possible, or more detailed, or we try to think of a new statistic. And the mission here is we exploit new data sources in collaboration with partners to obtain current and relevant information for users on societal problems by applying state-of-the-art techniques and methods. So it's all about developing new experimental statistics. And we also call them beta products, using these new sources or new methods on several themes that cover official statistics like health, labor market, energy transition, mobility, safety, etc. And we don't only focus on, well, our target is not to produce national statistics only, but we really are getting interested in international statistics and regional statistics at a very low level. And we also train our staff, which is an absolute necessity, not just the staff within the center, but also all the statistical divisions. We think about ethics, privacy, we do research on new methods, and we try to develop smart statistics, and I will talk a bit about this later. So these new data allow us to answer more complex questions. So how do we tackle the energy transition? Can we make early warning systems for refugee streams? How do we match offer and demand on the labor market? How do we make our businesses smarter? Or how do we manage mobility and pollution? They're all very complex questions. And what do you need in order to address these complex questions? And I'll go through a couple of components that are really essential. First, you need a team of multidisciplinarity. So we had a couple of people, of course, who had the relevant skills to do research. Survey methodologists, a couple of big data people, one visualization expert, etc. But we, of course, had to invest in more skills. We didn't have a lot of money to invest, so we mainly had to recruit a couple of people and reallocate resources, so really retrain the people we had to become expert in deep learning, machine learning, visualization, more of that, text mining. And we also recruited a data scout, which is somebody who really looks for data sources all the time. He's like very hungry and constantly looking for data. A big component of success to do this, to address policy questions, complex policy questions from an NSI point of view, is to build also an ecosystem. So you need to have partners involved with whom you can share the data that you don't have. And there are other advantages of having this ecosystem is look for funding, develop business models, and create societal relevance, to be close to the policy questions. The first thing I mentioned is to have access to their data is not so obvious. When it comes to universities and ministerial departments, it's kind of okay, but when you have private partners, this is not so obvious. So we're really looking closely now into developing research on privacy-preserved data sharing, so we can do this kind of data sharing in a private setting where none of the partners have the feeling that the other one is running away with the data. So that's a very important part of our activities. Another component of success for addressing these complex questions is to do the data scouting, and as I said, we already recruited somebody who doesn't do anything else than look for data sources. So this is just a snapshot of the sources he managed to find. In some cases it's just a test set, like smart meter data, but in other cases we have open access to KNMI data, that's weather data on solar radiation. We have TomTom data, floating car data, T-Mobile data, Cargonaut, and that's just a third of what he managed to get in-house. So that's a very important part of the story. I said we collaborate with partners, or we built an ecosystem also to attract funding. In this case, we got a Eurostat grant called Deep Solaris. And in fact, we do have registers that have the information on who has a solar panel on his roof, but it's not up to date and it's not complete. So this project tries to automate the process to extract the location of solar panels from aerial or satellite images, and secondly, produce a map of solar panels along with statistics on the number of solar panels. And in the first instance, we use the existing register data to create a training set for the machine learning algorithm. And in the second step, we evaluate the quality of the trained classifier. And if this classifier is functioning properly, we can actually complete the total number of solar panels that were not in the register. So I will tell you a little bit more about this project later. Another important component is to work with private partners in your ecosystem. I mean, we do try to develop models where both are happy. Where the intellectual property is protected, where we can come to an agreement in sharing data, where we're not an advantage, we're not creating an advantage for this particular private party by working with them. That's also important that we respect this. So in this case, the mobile phone data, where you see on the left Germans present in the Netherlands, and on the right the Belgians. So this collaboration with private partners is not an obvious one for a statistical institute. So we're really trying to find out what is an elegant way of developing these business models. I said another sixth component of success for wanting to address complex policy questions as an NSI is relevance, and the CBS also created these urban data centers. They're really physical rooms in a city where somebody from the CBS sits together with somebody from the city, and they think about a way to how the data from CBS can be useful for the city. So the city has a problem. They want to know, for example, how many electric charge pillars are there for electric cars, where and where should they put them? And we try to address these questions with the data we have in-house or new data. And that's really to be very close to the local policymaker, which in the past was insufficiently the case. Another part of this process is, seventh component, is the communication. So really talking to the outside world of what you're doing. And what we put on this website and this communication channel is our beta products, our experimental statistics, where we release information on the methods we used, the sentiment and cybersecurity indicator, the URL, small innovative companies, so all the products that we're producing, we're putting up there. We also change our the way we produce results. So we don't produce tables, or we try not to produce too many tables. We try to visualize things, and that's a different way of bringing out your results. And finally, a very important part of the work is that we merge the material we already have in-house, survey, admin, together with big data in order to produce these statistical products, because that's where the expertise lies. We know how these sources work, we know what the methods tick, and so now we have this new raw material which we have to add, and that creates the added value of information for new statistical products. So that's a big asset of a statistical office, and particularly the Netherlands, because they have a gold mine of registered data. So that's, of course, a success. Now, the second part of my talk, I want to address two questions. The first question is, are we still making the right statistics? And I'll try to address it a little bit. And the second question is how we go now from this experimental statistic to an official statistic, because you can experiment all the way and in a long time, and Eurostat has encouraged us to do this, but now Eurostat says, and now you have to implement those experimental statistics, which is easily said, of course. So, and one source I am a little bit in love with is sensor data. To say it with the words of Tom, actually, when he opened the conference in Barcelona, he said survey should be the last resort. And I would say sensor data should strike the first chord, because what I would like to say is that, in fact, you should first look at all the data that is being collected from ministries, companies, citizens, and then look at what kind of information is in there to address these questions. And if there's perhaps information missing, you could still organize a survey, but look at what's out there already. And sensor data offers a lot of potential. It's a direct measurement, so it's sensing. It's often real time, and it doesn't require the intervention of an interviewer or a questionnaire. So there's 3 waves over the past years. We have used sensors in automotive, with airbags, for example. You have the sensors in your mobile phone. And then there's Internet of Things offering a lot of potential of information that people could be of interest for users. And how can we recycle them for official statistics? Now I have to tell you a little anecdote. My daughter, when I practice my talks, I force my children to listen to me and give me comments. And my daughter came up with this comment saying, "Mommy, I really think that big data is gruselig." She said, "creepy," because people know everything about people, and I get very uncomfortable. And I have to say, when she said this, I was a little bit surprised, because I felt responsible for the fact that she thought like that. So, or maybe she discovered the sensors in her room, I don't know. But anyway, it was, and I think it reflects a little bit that if we're not careful and people perceive big data like that, then we cannot go on. So it's very important that you address these anxieties and these uncertainties. But okay, that's a different talk. I talked about sensor data, and we use it within CBS in 2 ways. As a primary source, so here we try to see whether some of the questions in the surveys, the budget expenditure survey, the health and lifestyle survey, the time and media use survey, can be replaced by sensor data that we collect in the mobile phone. So then you wouldn't have to ask people to say, "Oh, where have you been at that point in time? What have you done? How long did you spend?" We just use the information that they collect from their mobile phone through their GPS location. And then with prompts, we might ask them, "You are there now, what are you doing?" But so recycle the information that is being collected from the sensors that people have in their mobile phone or are wearing through a Fitbit. So there's a collaboration with the Ministry of Health where we ask people to wear a Fitbit, and all the information from the Fitbit is being used so that we don't have to ask the people anymore, how much did you move today, etc., etc. So really recycling sensor data and specifically installing sensors to collect that type of data. And a second way of using data is with the precision farming. We also make statistics on agriculture. So precision farm, we came in touch with a very innovative farmer who has drones flying over his potato fields, and he gave us his data, and we wanted to check whether the sensor data would allow us to fill in part of the questionnaire that we usually give to a farmer to fill in. Is there information in the sensor data that we can actually recycle so we don't have to burden the farmer with the long questionnaire? So that was the first thing. And the second thing we thought was, what is there information in the sensor data which we're not asking in questionnaires yet, but could be of use for a smart solution for the farmer? So that's the second. And indeed, we were successful in addressing the first question. We found in the sensor data a couple of questions we asked in the survey where we thought, okay, if we can fill them in already, we don't have to bother the farmer anymore. But the question is actually, do we want to stick to these old questionnaires, sometimes old questionnaires, which may not be asking the most relevant questions anymore? Are we addressing the information need of farmers in this case? Perhaps they need different information, not the kind of information we are trying to collect from these questionnaires. So in that sense, I think we should look much more into what is the information need of the user and address these with, amongst others, sensor data. Of course, it's not so easy to convince statistical divisions of this because they say, oh, we need to make the statistics that Eurostat is imposing on us. And we don't have money to make all these new statistics. So it's a process. But okay, we're facing this, of course, this different information need of the user. The second question I wanted to address is how do you go now from experimental to official statistic? You need three things. You need to do research on the quality of the data, on the new techniques to validate your experimental statistics. You need to train your staff, and you need to install a process so that you can have the EIT infrastructure to implement your experimental statistic, that your source is stable, and that you have a kind of implementation process installed. And the research we do is beta products, in this case, 2 examples of how we use machine learning to develop a statistical output, which used to be made with a survey. It's, okay, I'm not gonna speak too much about machine learning. The keynote spoke about machine learning very clearly yesterday. I learned a lot, so I'm gonna skip this explanation. In this case, I already talked about the classifying the solar panels, where we used machine learning technique to detect the solar panel, and the specific algorithm is called object segmentation. So it allows you to exactly know which pixel belongs to a solar panel and which does not. And on the map, the green dots are the solar panels, and on the red dots are the roofs without the solar panel. And because you know the surface of the solar panel, you can actually have an estimate of the yield of the solar panel. And the second thing we did was to apply a machine learning algorithm to a very large register that went back 17 years. Instead of bothering people with a questionnaire saying, are you planning to move within the next 2 years? Are you a swimming jellyfish, or are you an anemone sitting on a rock the whole time? We tried to see whether we could predict the propensity to move by letting loose an algorithm on a register and predicting the factors that determined moving. And the model was actually as good as the survey in predicting if somebody was moving or not within the next 2 years. So that's a relief, because then we can not bother the Dutch population with the survey anymore. So that was a little bit an animation of the question from the survey and the nowcast estimate of the machine learning algorithm. I have a couple of more examples. I think I'm running out of time. This is a new activity that we use. We try to use big data, text kernel data, to help create ontologies for the labor market, skills ontologies. So the whole issue in Europe a lot is the match between skills on the labor market and the demand, and the offer and demand of skills on the labor market. And a lot of the ministries, they create ontologies manually. So which skills are needed for which profession at which time. And through big data, we are trying to automate the process of creating ontologies. So that's a very interesting thing. I can talk to you later if you're interested. And then I had one more example on how we try to match survey data with big data, linking by record, by using the picture of the number plate. And the purpose of this was to look at the underestimation in the survey and to control the value that we found in the big data source with the value that we found in the survey. And this is actually the first time that we've managed to actually record link survey with big data, using a picture that was in both sources of the number plate. I can also explain a little bit more about this later. So I said we need 3 things for going from experimental to official statistic. We need research, we need training our staff, and we need a process where we check whether the source is stable, whether we have the software and the IT infra, whether we can combine internal sources with big data. And we have 2 products which already went from experimental to official statistics. That's the consumer price index based on scanner data and the traffic intensity. But for this year, we're hoping to implement at least 3 experimental statistics into the official statistical process, and this is one of them. This is AIS for maritime statistics, where we're looking into making it part of the official statistical production. And that's the end of my story. We had urban data centers, we had the CCN, the communication channel, and we had the CBDS as innovative channels in Statistics Netherlands. And okay, they're rocking the boat of an NSI, I can tell you, but they're making it much more interesting boat ride. So thank you very much.
Thank you very much, Sofie. It's been a very nice way of rounding up the 3 presentations with these fundamental questions. We do have time for a discussion around 15 minutes. So I would like to pose a question that it's of a general nature, because the problems that we're facing have been of a different sort in each of the countries. I mean, in Mexico, we do have our own time of challenges. Our admin record infrastructure is weak. So, I mean, that's something that we have. We have difficulties accessing data sources. So we are very hungry regarding data scouting, but we have been not as successful in grasping actually the data. And you also mentioned in different presentations the role of training, the human factor, and some of those things. So I would like to know from each of you, which do you believe is the most important challenge that you're being facing, or either in the past or in the near future, that you think it's the main obstacle in making progress in this agenda? Let's start with Tom, please.
Great question. For us, it is the shift from being an organization that turns the handle and produces thousands of statistical outputs each year, and basically a culture, a paradigm shift to being, how do we produce the information that underpins better decisions? And that means that every team is not thinking about the end of the process as being the publication of their statistic. The end of the process is when that data is being used by decision makers. So that brings in a whole bunch of extra things that they need to think about. So communication with the users, understanding user needs, getting close to your customer. It's a very business type conversation. And that then raises a question. If you're an independent statistics agency and your customer is government making policy, how close to policymakers should you get? And if you're a business, you would get as close as you can, but clearly you need to keep a level of independence. So there's a really great set of questions and conversations for each of the teams about how they step up the impact of their outputs and the impact of that data in decision making, which were not necessarily just about the quality of the data. It might mean timeliness, and both the other speakers talked about the importance of faster statistics. So you might be looking at experimental data coming out faster to add to the robust data. It might mean that you need finer grained, so sectorial breakdowns that you haven't produced before. So some of the work we've been looking at through the economic statistics teams is about producing a much greater volume of trade data. So I think the volume of data points that we published went up 1,000-fold after the data science campus have been looking at how much could we publish without this becoming disclosive. So there are lots of questions there, but it's that shift from statistics producer, and that being the end point, to underpinning decisions. That for me is the biggest challenge, and it's certainly what the ONS is going through. Lots of other things, but I'll hand on to the others.
Thank you. Eric?
Thank you, that's a great question. We have a very mature way of managing admin data at Statistics Canada. We have more than 10,000 files each year, so I wouldn't say this is a challenge within, but it's a challenge for us trying to more proactively occupy our space as leader of the national statistical system, so that not only are we seen as good stewards of our data, but good stewards of data of the whole national system. So that is a challenge. When we embarked modernization, the greatest challenge was the culture factor, trying to get people to embrace this modernization endeavor. And actually, I would say that over the last 2 years, the shift has begun to happen, and it's actually picking up speed to a point where I think the culture shift in how we perceive ourselves has gone faster than how society perceives Statistics Canada. So the idea of admin first, the idea of using alternative sources, working the statistical programs differently, this exists now at Statistics Canada, but society is not fully ready for Statistics Canada to put its hands on every types of data, be they payment or else or health, and then there's some issues. If we have access to DNA, if we have access to crime statistics, there's some questions that have not been fully debated, and so Statistics Canada exercising lots of leadership, we have to be very aware of our speed not being too much faster than the speed of society.
Sofie?
Sometimes they say that statistical offices are like dinosaurs from a forgotten era where things move slowly and they have this large data and they're old-fashioned. And it's an interesting statement because actually when you read the book of Steve Pritchett, he wrote a book on the rise and fall of the dinosaurs, and it's actually demonstrating that the dinosaurs were extremely successful species, and their descendants, the birds, they still are on the planet. So it's actually the opposite. So when they make these remarks about the dinosaurs, I'm also thinking, you know, we're still there, and what we do will survive because we are experts in data quality and methods in dealing with data. And so we have a huge role to play in society in view of all the fake news and rapid, dirty work. So I think it's quite the opposite. Unfortunately, not everybody is convinced of this, and so it's to find the people who believe in this and to drive the role of statistics institutes forward in society as a neutral, apolitical, quality standard institution. So, of course, with a great need to keep innovating, and that's the key, and go against resistance. So.
Thank you, Sofie. There are many questions here. It's a big data of questions, and many of them have to do with our own problems and challenges that we have in Mexico, and they reflect, I would say, a couple of problems. One is the legal framework. I mean, to the extent that INEGI, in the case of Mexico, but in general, national statistical offices are entitled to use public data. And this is usually admin data from departments in government administration. The other big sphere is access to non-governmental data, We've had problems accessing data with private sector counterparts. I mean, sometimes they show us, but they don't let us get into the data because some of this data has commercial value for them. So entering in some kind of partnership has been very difficult. But I have also a very important data. One of the questions was about the DNA of statistics. I mean, statistics are trying to be representative of a phenomenon regarding a population. Mm-hmm. So the question is, and this is very interesting, to what extent we're moving from the business of producing statistics to the business of data in general, of information. I mean, perhaps trying to force ourselves to produce statistics is a straitjacket, and then we have to move to a different environment outside of this straitjacket. I'd like to hear your comments about that. And Tom was in different arena from official statistics. What are your thoughts about this, the three of you?
I absolutely agree that statistical institutes should be thinking about data as a whole and not just the statistics outputs. So one of the pieces that the UK spends a lot of time working on is making the data that we hold available to researchers, and I know many other institutes will be doing something similar. So our secure research service allows access to the underlying microdata by researchers working on public good, and that's in universities, that's even in businesses if they are doing things that are public good and will be published. So it's access to that data. That's a kind of an example of the data that we hold and that we link together from multiple sources of providing extra value over and above the statistics that we produce. There's an argument that actually some of those outputs will be of equal value to some of our statistics outputs. So I think we have to look much bigger than just thinking about our statistics side. Talking about the kind of legal framework, I think, again, this is a really important one. So in the UK, we have the Digital Economy Act, where 2 years ago, we added a clause into a government bill looking at sharing data for government agencies to look at things like fraud and cybercrime. We added a clause into that bill to say all government agencies and all commercial organizations outside government, the Office for National Statistics would have the legal right, the gateway, to access that data and acquire that data for the purposes of research and statistics only. So not for targeting services, not for fraud or other parts of the system, but only for statistics. And what that gives you is a gateway which then people who want to share, but previously were scared that they would be pulled up in a legal sense, can now do so. So that underpins our work with Barclays, looking at bank data, our work on the other data sources that parts of government hold. So data, it eases that data sharing. You've still got a big problem because you have to go and talk to every single data provider. You have to build relationships. You have to convince them that you are trustable and so on. But there is a legal gateway. So that's a big shift, I think, over time. But the final one is, I think we're engaged in essentially a war for eyeballs. Now, this is a kind of a business sense, that if you're looking at advertising, you're competing for eyeballs on your adverts. We are competing for decision makers to use our data and our outputs rather than fake news, crap surveys that some group has run up in 10 minutes and got onto the front page for a PR piece. Lots of other things. We are competing with all of those. And so the brand and reputation of the statistics agency is absolutely critical to a decision maker thinking, this is a trusted source. I'm going to go to them first. I'm going to look at that work first. And so that's our kind of real big challenge, is to make sure that we deliver on that credibility and that reputation raising work.
Yes, and I would like to add perhaps that indeed the legal backing is extremely important, and there I raised the issue already with Eurostat, and they ask us a certain type of statistic. And when we talk to farmers about the information they would really like, that's something else than what we make for Eurostat. So, and there the conversation with the user is so important, and the farmer has some very clear ideas of what he wants. They're often a very strong head, stubborn group. So, and it's very interesting to see that it would be great if the user would get a bigger voice through us to lobby for a different type of official statistic, but where the need of the user is the focus. You know? And I think that's urgently time for that questioning existing official statistics. Yeah. Mm.
I do concur with my colleagues. Yes, the DNA of statistics is to produce, the DNA of Official Statistical Office is to produce official statistics. At Statistics Canada, we have 3 hard principles through which we try to see our programs. Producing information that allows valid statistical inference, quality and rigor. And so we can still be within those, but at the same time, we have to explore how can we better inform society. And if I can actually cite a paragraph of the Statistics Act, which I happen to have with me at all times, one of the roles of the Statistics Office is to generally promote and develop integrated statistics. So it's not just produce statistics about this or that, but it's develop and integrate and promote, and we do that in partnerships. And for this to be used as official statistics, we have to constantly renew the trust in the Stats Office. And as Tom said, we have to kind of market ourselves, and one way of doing that is not just engaging someone in marketing, it's actually occupying the space of what do people need, and still trying to produce information which is valid, quality, and rigorous.
Thank you very much for your reaction. We're basically on time. I'm going to give the questions to the organizers so that we can collect some kind of answers through an informal way, either email or some other source. But I want to thank our own panelists, Tom, Eric, and Sofie, for their great presentations, lively discussion that we had. Please give them a round of applause.